Hello and welcome to today's webinar, Discovering the 5 Critical Characteristics of a Modern Data Warehouse. Today's event is brought to you by Cloudera and produced by Actual Tech Media. Now, before we get started, we have a little bit of housekeeping we need to cover. First off, my name is David Davis. I'm a partner at Actual Tech Media, and I'm excited to be the moderator on today's event. Now, before I introduce today's presenter, I want to do just a little bit of housekeeping here that you need to be aware of. First thing, we want this to be a really educational event. We put on these webinars to help educate IT professionals such as yourself about the latest and greatest in enterprise technology, and that's the purpose of this webinar. So we hope that you learn a lot about data warehousing and the pitfalls, things to look out for, challenges, and solutions. So feel free to use that questions box there in the GoToWebinar control panel to ask all the questions you have during the event. We'll have a dedicated Q&A session at the end of the event where I'll ask the best questions to today's expert presenter. We also have a $300 Amazon gift card that we'll be giving out to one lucky attendee on the live event today. The prize terms and conditions can be found at our website, events.actualtechmedia.com. And with that, I'm excited to introduce today's presenter. That is Mr. Joey D'Antoni, Microsoft MVP, VMware vExpert, author of numerous books. Joey, thank you so much for being on the event today.
Thanks, David. I'm looking forward to it. Welcome, everyone. Like David mentioned, I'm Joey D'Antoni. I'm principal consultant at Denny Cherry & Associates Consulting. I've been working with various data platform solutions for the last probably 20 or so years. I'm getting a little bit older now. So I've had a wide experience and seen a lot of things through my time. Before I was a consultant, I worked at a cable company you guys have probably heard of in the Philadelphia area. And I did a lot of this big data stuff there. And it was really kind of interesting to see how the world was transforming just from a simple traditional data warehouse that was based on a relational system to a more complex, multifaceted systems. So one of the things that's changed in the last decade or so is businesses have an ever-growing thirst for more complex data, and there's really two major factors, or maybe three major factors, in my opinion, that are driving this. The first is IoT, Internet of Things, and that really tends to come from like the production side and the supply chain side of the business. So you have situations where you maybe want to know where your inventory is, how quickly that data is driven to customers, and when is it going to get there? And that's kind of driven by a couple of other business trends like just-in-time manufacturing. The other two bits of or major trends that are kind of societal trends that have driven this data are social media and mobile devices, and those kind of come together. So social media, the use of Facebook and Twitter and even LinkedIn and other networks as marketing have really driven a lot of traffic and just data throughout the world. So there's a lot more data coming from those systems than you wouldn't ordinarily have when your data warehouse just came from your maybe point of sale systems, or maybe your actual physical warehouse. So those social media sites are looking at things like sentiment analysis and launching new campaigns and seeing how they hit, and you're going to have business needs to get that. The other kind of trend that ties those two things together is mobile apps. So really, this frankly started with the invention of or when Apple released the iPhone, and I don't even remember, I think it's 2007, 2008 timeframe now. Maybe a little bit before that, but having mobile apps that collect a lot more data also really drives this need. So this means we have more data coming in from more sources, and it's coming faster. And we'll talk about the 4 V's later, but when we talk about velocity and volume, this is something that happens. The other thing that's kind of a trend in this, and in general to me, it's just an overarching trend I see when companies roll out data warehouses or analytic systems, is that there's always going to be a trend to go towards more real-time data. So if you start by a real common pattern is you do an end-of-day batch load into your data warehouse, eventually the business is going to get to the point where they're like, we don't really want these reports to be 12 hours behind. Can you load every 4 hours, and we can see them that way? That happens. and then they get 4 hours, and then eventually you're almost doing real time. And one of the kind of interesting things to think about is from a cost of development and engineering solutions, it's always going to be more expensive to go nearer to real time, because you're switching from something where you can do batch processing of that data and loading it into a data warehouse to where you're having to do real-time change data capture, and your ETL becomes a streaming process, which is doable, but it's harder and more challenging. But so we have all this data and we have all this complexity, and data warehouses have kind of evolved over time to take advantage of all these things. So some of the things they've tried to do is eliminate analytics and operational silos. So we try to get all of our operational data from flat files, data coming from those IoT devices, mobile data, all into one place. And we kind of deploy, we show this in the slide as a really high level where we have summary data, metadata, and raw data. The way this tends to work out technically is that we have many systems that make up this warehouse now. It's not just necessarily one system, or if it is one system, that one system is linked to a few other types of systems. And we'll talk about the way later in this presentation how more modern architectures come together and how different components serve different needs. This is also something that's greatly enabled by cloud, because there is, in a pre-public cloud world, especially if you were a smaller organization, there was a lot of overhead towards providing those different types of data services. So companies tended to go with one, which was nearly always the relational database. But on the case here, where we have on the right, where we see users, and we have analytics users, reporting users, and mining users, they're all pointing back into the warehouse. But frankly, that could be 3 different systems and optimize for each of those solutions, but it's patterned under one platform. So that one platform will serve those multiple disciplines. The other thing that we want to do is provide self-service BI that's almost like software as a service. And a lot of this is driven by BI tools like Tableau or Power BI that enable those kind of capabilities. This is typically combined with some sort of semantic layer, so that your users aren't having to write SQL queries against your data, or HQL queries if you're using Hive, directly against your data warehouse. So you want to have an area where they can use a BI tool like Power BI or Tableau, or even Excel, which is probably the most popular business intelligence tool in the world. You also want to support integration with your monitoring utilities. So this is kind of complicated, because we have a lot of, I don't want to call them legacy systems because they're current, but we have a lot of mature platforms like relational databases that integrate well with monitoring utilities. And we have newer platforms like Cloudera, Hadoop, for example, which does integrate with monitoring utilities, but in a different way. So you may end up using a different set of monitoring utilities to maybe pass through that feed. So like if you're using a Hadoop cluster, you're probably using Zookeeper to manage the cluster, and you want to make Zookeeper integrate with your monitoring tools, or maybe even you'll use tools like Grafana or Ingress that are open source performance tools that can perhaps feed into your other monitoring solutions. So some characteristics, and we'll walk through each of these as to what we're going to talk about. Modern data warehouses have a characteristic of invisibility, and this is a little bit of an odd way to phrase this, but what it means is that it should be completely transparent. I think transparency might be a better term, transparent to your business. So your business users just expect to have this almost, I like to call it data as a service platform. I've actually helped the customer build one of those, that they just know that they're going to be able to go out there and do the analytics they need to do to get the answers to the questions they have about the business and what's going on in the business in order to get those answers. It should just be there. It should work. It should perform pretty fast. It should be reliable and secure. We're going to talk about the data security management. One of the things that's always a little bit challenging around ETL processes, and if you're not familiar with ETL, that means extract, transform, and load. And that's kind of a classical process where we take data from our source systems and move it into our warehouse in a structure that's optimized for reporting. By doing that, we generally speaking try to strip out personally identifiable data because we tend to care more about aggregations. This gets messy, and we have a lot of rules now, especially around GDPR and other various data privacy laws. So you want to be careful about that. So we're going to talk about mainly classification of data, but I'd also like to kind of throw out encryption. And depending on what platform you're on, encryption can be harder or easier to do. Scalability. This is kind of one of the biggest trends I see, and this is, to me, it's another trend that's sort of driven by cloud architecture. Is that in a lot of cases we're trying to separate the compute capacity that we have from the storage capacity, and it really shows up on these larger analytic systems. Because if we think about what a data warehouse is, it's all the data from all of our operational systems. So it's not only the sum of that data, but with additional aggregation. So it tends to be very large. So we want to, if we can separate that compute layer, and we can even scale out that compute layer, and we'll talk about how that works in different capacities later in the deck. But if we can separate those things, we can tune our performance accordingly and adjust our cost. Modern data warehouses all have cloud capability. I think the public cloud's a wonderful thing. It opens up a lot of avenues to smaller organizations to do things that larger organizations have been doing for a decade. Just to kind of give you a reference there, with either Parallel Data Warehouse, which is a Microsoft product that ultimately became analytics platform system, which is now Azure SQL Data Warehouse. That's a massively parallel scale-out data warehouse. In order to buy the on-prem version of that, you had to spend about $1 million to get your foot in the door. You can get started with the cloud version for $5 an hour. Likewise, Hadoop. Hadoop wasn't that expensive relative to like what that Microsoft product cost, but if you wanted to do it on-prem, you had to buy a lot of servers with a lot of storage. And even though it was still cheaper than buying SAN storage, it was a lot of money. I know when I built a 100 node Hadoop cluster at Comcast when I was in 2013 timeframe, and we built it on physical hardware. And it was, I believe it was over $1 million to buy the hardware for all that. And it's not that any individual server is expensive, it's just that you have a lot of them. And then finally, we're going to talk about the versatility of modern data warehouses and their ability to be able to kind of deal with varying types of data. And I think that's kind of one of the more interesting parts. We're not just talking about sales data anymore. We're not just talking about inventory. We're talking about all sorts of data and all these trends and how we can bring them together and help the business make more data-informed decisions. So what we mean by this invisibility is a usable data warehouse to your business users, and we want application level invisibility. We want this to be fast. So one of the kind of interesting trends that's happened with I'll just say data analytics type of applications is storing data in a columnar format. So columnar storage really goes back to the 70s, and the first modern practical implementation came in the 90s, which was by a company that was acquired by Sybase. It was a company in the Boston area, and a lot of the early R&D came out of MIT with this. And if you're not familiar with columnar storage format, if we think of traditional database table that's in a table, that data is typically just kind of chunked into, depending on your database, somewhere between 8 or 64 or maybe even 32K blocks or pages, depending on your operating system, what you call that thing. But it's chunked, and a certain amount of data from that table is taken kind of in the order that it's stored in the table, is stored on that page or block. There's no real logic to how that's stored. It's from a mix of rows. That's a very efficient method of retrieving a single record of that data, and it's also a pretty efficient way of inserting a single record or updating single records of that data. However, since we know in a data warehouse system we're mainly just going to be doing bulk loading and then aggregation of data, what we've kind of optimized for in open source systems like Hadoop, this is going to be Parquet format, and in SQL Server, it's going to be column store, and in Oracle, I think you have to buy Exadata to get this tech, but it's called hybrid columnar compression. Instead of storing the data like that, what the systems do is store the data, the table data itself, in in columns. So each column is its own storage on disk. The benefit of this is twofold. First, if you have data stored in columns, you can compress it way more than just having a bunch of random data on a page. So what that means is, since if you think about it, if we have a list of addresses, and we have California's got the most residents in the US, so if we have the state repeated, 8 million times, or however many people live in California, we're going to have a great deal of reduction in that column. The other benefit is we don't have to scan those columns for queries that don't use them. So if frequently in data warehouse type tables, you'll have a fact table that can be pretty wide. It's got a lot of information in it. You may only be scanning, 5 or 7 of 50 columns in a table. In the past, you would have had to build a pretty complicated set of indexes and understood exactly what queries users were running to make that work well. Now with columnar format, every column effectively becomes its own index. So that means you're only scanning the columns you need. And it's a very efficient way of doing it. So you get a twofold benefit there. You're storing less data on physical disk, and you're also retrieving it faster. So there's a whole lot of benefit there. Now that our CPUs are pretty fast and can deal with that compression, it's a really good thing. And like I say, Parquet format in open source world, column store in SQL Server, but columnar is kind of the overarching term. So data security and reliability measures shouldn't impact your user experience. So one of the other things that we're going to talk about here in a bit is keeping this stuff highly available. And this always comes down to the SLA you define with the business, but let's just remember that these systems are business and tend to be executive facing, because let's face it, executives want to know how much money they're making, and how much money things are costing. So these are pretty mission critical systems. The days of treating your data warehouse as a second-class citizen are no longer. And data security should be efficient and transparent. We'll talk more about that here in a bit. So in terms of administration of a data warehouse, we have a few things here that we want to talk about. Automating data collection and maintenance. So, and this is probably more so in relational systems than systems like Hadoop, but in relational systems, we frequently have to do data maintenance. So we have to make sure we have up-to-date statistics on our data, and we also have to make sure our indexes aren't fragmented. Those are things that need to happen kind of quietly and seamlessly. You want to ensure whatever platform you're choosing supports doing that stuff online. And this is another one. You want to minimize manual schematization of incoming data. So this is really, I'd argue this is probably less of an administrator function and more of a developer function, or even a BI architect function, in that you want to build an automated process to deal with incoming data, so that you handle error records correctly. Nothing too weird happens. You want this to be as simple as possible. In order to do that, though, there's a decent amount of technical work you have to do, and relatively speaking, that's the easy part. You need to kind of work extensively with the business and the other application teams in your organization to make sure that if any changes come into the data you were expecting, that they're coming, and to adjust your code. There's talk of doing some like AI or machine learning based solutions to address this, and there are some really nice solutions. Microsoft has a set of libraries called Pros that do text file analysis and do a really good job of cleaning up bad text file data. But at the end of the day, all that is a series of if statements to handle certain conditions. So if more conditions are coming in, you need to be able to do that yourself. So just staying on top, having good communication there with the app teams is really critical. Finally, easy deployment of data classification techniques. And I'm going to speak specifically to SQL Server here, probably because it's the database I know best, but this is data classification is kind of a hot new trend, especially in light of GDPR. What data classification allows us to do is effectively to tag data and say, these records are affected by GDPR. So for example, that would be maybe if you had a customer's dimension, that would be any customer that had some connection to the EU and were therefore affected by GDPR, or any records, your entire customer's table would be labeled as GDPR because potentially they all have connections to the EU. So automating this and building it into your model at a high level is pretty important. And newer versions of data systems all have support for being able to tag your data with this metadata so that you can easily know, maybe what data you'd need to get rid of if you had a GDPR problem, or if you just want to filter or even do things like row level security. So building reliability into your data warehouse, this is kind of an interesting conundrum, because I know when I was growing up, we cared more about operational systems than we did our data warehouse, because we thought of it as being secondary. In the modern world, we really don't get to take that liberty anymore. Remember, these are business critical systems where executives and managers and directors are making business critical decisions. So no matter what kind of data solution you're talking about, you want to build it on fault tolerant infrastructure. This can be one of the benefits of moving to a public cloud, or even a virtualization, or even a containerized solution. David and I were talking a little bit before this call about how you can do Cloudera Hadoop on containers now, and I think those solutions are all interesting, because one of the things, and this slide shows SQL Server availability groups, but one of the things to think about is if you're on a platform that has some level of high availability built into the infrastructure, you don't necessarily have to build that availability in at your data tier. You can just take advantage of the underlying infrastructure. So here, we have 3 databases, or 3 servers that are in an availability group, and they're all feeding into a data warehouse. And the interesting thing about this slide is that we're not showing the data warehouse being redundant. There's kind of 2 approaches to this, and one of the neat things you can do specifically with SQL Server, but other solutions as well, is you can scale out your reading by using high availability technology that allows for readable secondaries. In the case of Hadoop, it's a little bit different, because we're not necessarily, because it's designed to be a scale-out solution from the get-go, high availability is built into the platform. So if we lose a node, everything stays up and running. This is really critical for data as a service vendors. And I have a customer who's in the data as a service business, and we've kind of gone with an interesting model that's a mix of infrastructure as a service offerings and platform as a service offerings. Basically, they have a big data warehouse that they fulfill their data as a service needs from. So in their case, that's a highly available environment, both in terms of infrastructure high availability and database high availability. So they do have redundant copies of their data to protect them. But what they're doing from there is feeding that data to their customers, and they're giving their customer a platform as a service database. The advantage of that is, in that platform as a service database, backups are taken, the database is highly available. They have the option for disaster recovery if the customer wants it and wants to pay for it. Obviously, that's going to double their infrastructure costs, so they pass that along to the customer. But that's always something to think about, is how highly available you want to make your environment. And the key thing here is to have a good understanding with your business of what you're going to provide them. So obviously, if you have one server and you have a 2-node VM cluster and you have 2 database servers, you're going to have a hard time providing high availability. But if you're in the cloud, or you have a really good budget, it's going to be far less important far less expensive for you to take advantage of those things. Backup should not impact the performance or interfere with your ETL workloads, and for the most part, that's a non-issue. Where backup gets a little weird is, especially when you're dealing with kind of non-traditional, non-relational systems like Hadoop, you want to think about what your data backup strategy is. Hadoop really isn't designed to do backups. However, the underlying storage that you're on, because it's an object-based storage system, can be replicated. You can back up that storage, especially if you're in the public cloud. You have a lot of options, and you want to think about them. Backups are traditionally not something that's always thought of in data warehouse world because the data is all coming from source systems. So theoretically, it's reproducible. But as you get into those larger volumes of data, it becomes dramatically more difficult in order to bring up those bring back that data. And so you can't just have one copy. This is one thing to always think about. You want to have multiple copies of your data just to protect you from corruption. If you're using a cloud provider, you're probably going to have 3 copies of your data. If you're using Hadoop and you haven't changed the defaults to be bad, you're going to have 3 copies of your data. You can even potentially, in both Amazon and Azure, you can have geo-replicated storage so that you have your data across 2 regions. And especially with a system like Hadoop, or even to an extent Azure SQL Data Warehouse, you can have that data go to both regions and then just re-stand up your compute part. And that's kind of one of the cool things about separating data and compute. One of the things I always like to tell customers in the cloud is that because of the way the cloud's architected, it doesn't really make a whole lot of sense to back up your database servers. It makes sense to back up your data. So you want to, it's what I'm trying to say there is if you have, say, relational databases, you want to ensure that you're taking regular backups and you can do point-in-time recovery of those. But because the way the architecture in the cloud is, it's much faster to stand up a new VM and restore those databases to that VM than it is to do a full restore of that VM and then bring the databases into a consistent state. So this can also apply if you have a pretty automated on-premises VM environment. Just something to think about. And once again, it really, all these decisions come down to the SLA for recovery time objective and recovery point objective that you have with your business. And remember, you should treat these just like any other operational systems you have. Security. I always like to talk about data breaches and how important security is. Your data warehouse contains a lot of sensitive business data. I'm going to step aside here and not talk about databases for a second because I'm going to get on my soapbox. I just kind of assume that everybody's going to get phished and they're eventually going to have some sort of malware or ransomware attack their environment. The most important thing you can do to secure your network has nothing to do with data encryption, any of this. It's important, all that stuff's good. The most important thing you can do is network segmentation. So if you're a director or a manager or even an architect and you don't know how your network is segmented, you should go up a level and talk to some network architects, your CIO, whoever you have to. Basically, what I'm trying to say is if you can connect directly from your laptop to a database server, your network is probably not as secure as it should be. And yes, it's a pain in the neck or other body parts to go through jump host and connect, but it's really critical because here's why. When your CEO gets spearphished and clicks on an attachment that ransomwares the company, if that's limited to your desktop network and your database servers and your domain controllers and your analytics environment are all in a protected off network that's firewalled off and can only talk to each other, you have a couple of days of re-imaging people's desktops and it's not that big of a deal. If that hits your server subnets, you have a real problem. So to me, that's kind of my soapbox thing there. I always like to mention network segmentation is absolutely critical, and it's probably the single best thing you can do to protect yourself from attacks. But that being said, wherever your data resides, it has to be secure. Data encryption, and let's talk kind of about different layers of data encryption. We have data at rest encryption. To me, this is one of the things that the cloud providers make a lot easier than things we used to have to do on-prem, mainly because the cloud providers are willing to manage your certificates for you and just encrypt your data at rest using their certificates, which is a very easy way to encrypt data. That being said, encryption at rest, especially in the public cloud, all it really buys you is that, you know, if somebody gets unauthorized access to your account, they can't download it and download a file and open it. In the past, we would say if they had a hard drive, they can't open it. What we really want to make sure we have in place is that we have any critical PII data that users have access to that they don't necessarily need to see, or only certain users need to see, that data should be encrypted in the database. And this is a little bit more challenging in open source databases like Hadoop, but there are offerings there to do that. You can encrypt that data on the way in. You can pass the keys to your whatever application needs them to decrypt them. SQL Server has a great feature called Always Encrypted that's in SQL Data Warehouse as well. Where the way that works is the application itself holds the encryption and decryption key. So the data is never stored in the database in an unencrypted format. It's never been passed through to the database in an unencrypted format, and you can index it. Once again, your connection should be encrypted as well. If you're using cloud data services, they tend to be automatically encrypted. Most of the ones I've worked with do use TLS or SSL, depending on the service. However, there are some tools where you may, or if you're on-prem, you may have to do that yourself. And then you need to classify your data into security levels. So this is probably a little bit more challenging, because this is one of those situations where you need to sit down with your business group and talk about what kind of data they have, what the situation is, how the data should be classified, and what's PI. I mean, obviously, sometimes it's very obvious what data is. I'll tell a little bit of a horror story I ran into in a health check one time. I was working with a company that did some payroll service type stuff, and I was trying to solve a performance problem for them, and I happened to run across a job on a server that said, you know, something SSN job. And I was like, oh man, that doesn't sound good. So I went to look it up, and sure enough, I quickly identified a table that had like 400 and something thousand unencrypted social security numbers and all the other data you would need to steal someone's identity in the table. But wait, there's more. So what happened from there is it turned out they had their database servers linked to each other, and those link connections ran as the system administrator account. Except if that wasn't bad enough, the final straw was one of their servers. Any authenticated user had access to that server, which meant if you connected to server 1, which was connected to server 4, which had the SSN problem, you were effectively system administrator on server 4. So you could download the data with no audit record. It was just bad. Don't do things like that. Think about your data. And this gets overlooked a lot of times in warehouses, because the data will get moved in, and then people don't think about it as much because it's analytics and it's kind of secondary to operational systems. So avoid blanket security rules to all data. You really want to narrow this down to the types of data that you're dealing with. You want to use role-based security. If you're not managing, that's going to be a nightmare, and that just is pretty kind of a basic tenet of security. The other thing I like to mention here is, especially as we talk about public clouds, you need to think about who has access to your cloud infrastructure environment and who has access to your data, because remember, those are two separate things. I like to talk about in cloud, to me, the cloud's made up of a bunch of little boxes that you manage. You need to think about who has access to that management layer where you manage the boxes, and then who has access into the boxes. Business units should be able to only access the data that they require. This is kind of a key principle. You can do this a few ways. You can use row-level security, which is pretty common. Row-level security can also be expensive and to implement in terms of performance cost. So one of the other things you can do is just break down your reporting structure into different OUs, or provide a different maybe reporting layer. And we talk back to that semantic layer. That's typically some sort of in-memory layer. So maybe you don't provide access to the whole data warehouse. And this is just a general rule. Your users should not be able to access everything in the data warehouse by default. I think the number one reason why I like having that kind of security in place is just because there's a high likelihood that if some user does, they will try to download your entire data warehouse into an Excel spreadsheet. And that's not good from a security perspective, and it's not good from a performance perspective. So you want to kind of avoid those sorts of pitfalls. So when we talk about compliance, just to kind of step back, I'm way too familiar with this because I worked in pharmaceutical and medical device for over a decade. So I got all sorts of intimate information, but personally identifiable information does require additional levels of protection. And especially if you're in a publicly traded company, you're going to have to undergo regular audits, and you want to do these both internal and external. Having a good internal audit team will save your bacon, because when external audits come up and you're in violation, that means your company has to spend money. Recently, there were some pretty big GDPR fine announcements. I think British Airways got fined, like, I can't remember, but there were a few commas in the fine. It was a big deal for a data breach. So you want to, and really, I'll kind of say this just from a data warehouse architecture perspective. You really want to think about if you need that personally identifiable information in the data warehouse. Perhaps you need a way to identify high value customers, but frequently what you can do is mask that information using tokens or things like that. And then the privileged users who need to get that information can then go retrieve that information from maybe another system. That's kind of a common design pattern. It's way easier if you don't store any of that PII in your warehouse, where it's repeated and it's hard to manage. But we have these frameworks like GDPR and HIPAA. These are things that are pretty important, just from A, they can cost your company a lot of money, and then B, you don't want to be in violation. Nobody wants to leak people's data. And like I said earlier, and I'm not going to get off my soapbox on this because I think it's so critical, you can protect yourself in so many ways by doing good network segmentation. So if your network is good, you don't have to forget about this stuff. You still have to do it, but it's something you really want to think about. And then you don't want to sacrifice usability, but a good security model should be transparent to your users. So here we talk about three V's: data volume, variety, and velocity. These are all increasing, and the main things we see here are IoT. So IoT data is kind of interesting because that comes in a lot of ways. It can be streaming ones and zeros, but it can also be audio and visual data, which is both high in volume and high in variety, and we have different ways that we have to deal with this. So this means we're getting a lot more data. A lot of the data we get from mobile apps and social media, that data comes in as JSON, and we need a way to manage that and parse that JSON and get it into the format we want. And it's not just necessarily a Mongo story. Your data warehouse needs to be able to keep pace at both ends of the architecture. So it needs to be able to deal with that variety and deal with that velocity and volume. And like I mentioned earlier, one of the ways that I see a lot of platforms doing this, and it really is a lot clearer in the public cloud, is that if you can separate your compute tier from your storage tier and scale those independently, so as the amount of data you're storing goes up, you may not have to have more nodes because you could have efficiencies, but it also lets you, by doing that, it lets you choose different computing engines for different parts of your data and different approaches. So for example, the machine learning stuff, that might not be the most efficient way to do that in your data warehouse. You might want to use your data warehouse as a source and pull an aggregation, then do your machine learning, whether it's R or Python, somewhere else that's more optimized for that, like a Spark environment. We'll talk through that architecture in a couple of slides. So here we see this example of independent storage and compute. So your metadata storage and processing shouldn't interfere with your business critical data processing. So if we look at, this is an example of Azure SQL Data Warehouse, and just to kind of walk you through this architecture and how this works. SQL Data Warehouse has one control node. And front-end queries will go through that control node. However, we see those compute nodes in the back end, and depending on how much money you give Microsoft an hour, Microsoft gives you more of those compute nodes. And the way you load your data into this is that your data gets loaded as in whatever file format it's in, whether it's CSV, Parquet, ORC, there are a couple other ones that gets loaded, excuse me, that gets loaded into Azure Blob Storage, which is an object-based storage model. That data is loaded directly into those compute nodes, bypassing the control nodes. This gives us horizontal scale. As in this specific example, it's a little bit complicated, mainly because of those DMS things you see, and that's going to move data across nodes for joins. Without going too much into the architecture of SQL Data Warehouse, it's much faster to move data up and down that stack than it is across that stack. So partitioning becomes important as to how you do this, and partitioning is always really important in data warehouse design, and because moving data across the stack's expensive. It doesn't matter if we're in Hadoop or if we're in SQL Data Warehouse. It's just kind of a general principle. But the point of this is we can scale our compute tier without scaling our data tier, and we can do these independently. If you're using a hybrid architecture, you need to be able to burst the cloud when necessary. And I think it's important to kind of understand where your burst capabilities fit and how that works. That tends to be a little bit trickier to do in these analytic systems, just because the volume of data you're talking about, moving that data to the cloud all in one shot to do a burst can be challenging. So a lot of times when we see these hybrid infrastructures, they will have vastly distributed operational systems. So if we think about point of sale systems, those are kind of always inherently going to be on-prem, and they may all feed data back to a central cloud warehouse. Finally, you can leverage machine learning to kind of improve your performance. And this is taking your performance data and looking at it over time, adding some machine learning functionality to it to make it smarter. That's kind of like 500 level stuff in terms of what I've seen folks doing, but it is definitely possible because there are patterns, and what you can do with that is you can know when to scale, and you can kind of reduce your overall spend because you can scale up and scale down as needed. Usually it's not that smart. It's kind of somebody detecting a pattern and then writing a shell script in order to do that. So your compute component should remain easily configurable as more data comes in, and your scale and complexity of the data can become a business advantage. The really nice thing I think about this is you can add a couple of different compute tiers, and let's talk about that as we move into the next couple of slides. Excuse me, I skipped a slide there. We have multifaceted data, as we talked about. So it's increasing data variety. Many applications use data types that aren't limited to standard text or integers. Whether it's geodata, I have a customer that's doing a lot of work with geographical shape data. Whether it's mapping data, and that data tends to be in the form of a graph, statistical analysis, and how we organize this data and how we build these frameworks can be quite a challenge. And the next slide is kind of a demo of a modern data warehouse that I like to talk about. So actually, this is probably going to be our last slide because my machine rebooted while we were doing this. But just to kind of take you back, we were talking through this slide, and we have the data on the left, and we kind of move from left to right to where we do analysis. So we have that analysis, and that can be Hadoop, that can be Spark, that can be in a data warehouse. And then those systems tend to feed in the decision support systems that we give to our executives. So those tend to be reporting and dashboards, text analytics and search, depending on what they're doing. We can also feed kind of aggregated data to our data science teams that are doing even deeper analysis on that. And that's about all I had on that slide. And since I can't get back into PowerPoint, that was our second to last slide anyway. The next slide is really just, you want to be aware of private or public cloud and how your data is going to interact with that. So David, I was wondering if we had any questions from the audience as we kind of wrap up here.
We do, Joey. Yeah, we do. So let's see. I mean, the first question that came in, they're asking about, you talked about the 5 different characteristics of modern data warehousing. I mean, is there one characteristic that's more important than the other?
So we kind of left this off of this deck because it's kind of inferred, but to me, it's the most important thing, and that's the quality root data. So all the data warehouse technology in the world doesn't really do you anything if you don't have good data. And so it's important that you rationalize the data you're getting with your business and understanding that you're getting meaningful data from them. That's probably to me the biggest tip I can recommend, and that goes really beyond the scope of your data warehouse architecture. It really goes into your data architecture and answering the right questions for the business.
Yeah, that sounds like the forgotten bonus characteristic there that everybody needs to be aware of.
Let's see, for sure.
Next question here, they're asking about, what's the biggest mistake? I know you've done a ton of consulting. You've built a lot of data warehouses of all types. What's kind of the biggest mistake that you see people out there experiencing, and what's your recommended solution for it?
That's a good question. There are a number of things, and really, I think the biggest is kind of focusing a little bit too much on maybe their data presentation and what their reports look like, rather than getting their core ETL processes in place. The other thing is not isolating the business questions that they need to ask before they build the data warehouse. So just kind of going in and generically building a data warehouse can be helpful, but it can also lead to you maybe having too much data or not enough data or not the right data. So really having that understanding from the business of what they're looking for, and really this all comes back to kind of relationship management. No matter what you do, there's kind of a design pattern for how you implement an analytical system, whether it's a relational data warehouse, whether it's a Hadoop cluster. There are all these ways that you can do these different things, but it's important to understand what the people who are paying for it want to see, what questions they want answered, and how you're going to get to that end.
Okay, good advice. Let's see, another question here that came in. They're interested in moving data to something like Hadoop and Cloudera. What do you typically recommend if they wanted to get started with something like that? What's the first step?
So that's a good question, and kind of one of the easier ways to get started moving data into a NoSQL platform like that is just to do a trial. It's very easy, and I don't want to sound like a total shill for the cloud, but it's a lot easier to do this in the cloud than it is necessarily on-prem, just because there are some downloads you can do. Like Cloudera has a container you can download. There's a standalone VM that you can get from them as well. That's kind of cool. That's got all the tools in it, but it's hard to do any real data experiments because for this to work, you need scale out. So if you can get your data into a public cloud, and whether that's Amazon or Azure, it doesn't matter. You can then build Hadoop on top of that. That becomes quite easy to get started. I'll say if you're coming from a relational background, there's a tool that's part of the Hadoop stack called Hive. That's basically a SQL layer on top of Hive, on top of Hadoop, that will be pretty familiar to you, especially if you've done any sort of flat file loading into a data warehouse. It's a pretty straightforward, it's a pretty easy transition, albeit it may be a little bit limited compared to some of what you're used to.
Okay, sounds great. Yeah, sounds real easy to get started. Like you said, cloud makes it easy, and then there's virtual machines and containers that you can just download and run on your desktop to get started. Learn more about it, get maybe some test data in and start seeing how something like this, might work. Joey, it's been a really great educational event here. I've learned a lot. Let's see, one more question before we go, since we have a couple minutes, just popped in. Do you have any recommendations for the best tools and resources to manage data quality?
That's a good question.
We can get back to that one if we need to.
Yeah, I honestly don't. There's not. It's a kind of like data. There are some data quality tools that will help you, master data services type tools or data quality tools, and that will help you with is just straight up data quality type issues. So like correcting bad addresses. But to ensure your overall data quality, that's kind of a complicated business process, and I need 3 hours to talk about that.
Okay, awesome. Sounds like someone might need some of your consulting assistance there.
Yeah, we're always around. Joey@dcac.com.
Awesome. All right, well, Joey, thank you so much for being on the event today. It's been really educational. I've learned a lot. I know the audience has as well. Before we go, I want to announce the winner of our $300 Amazon gift card. That's going to Sean Voss of Minnesota. Congratulations, Sean. We'll reach out to you to deliver your gift card. Joey, thanks for being on today.
Thanks, David. Be in touch. Talk to you later. Bye.
And thanks everyone out there in the audience for joining today's event. For more information on what you learned about on the event today, make sure you visit cloudera.com. Have a great day.